Buenos días, soy Romulo Castro de Panamá. Vengo de una familia de emigrantes en muchas direcciones.
Good morning, I'm Romulo Castro from Panama and I come from a family of migrants in many directions.
Familia materna española de Valencia, republicanos que perdieron la guerra civil.
On my mother's side, we're from Valencia, Spain, and they were Republicans who lost the Civil War.
Emigraron a México, a donde luego llegó mi papá desde Panamá y allí nací.
They emigrated to Mexico, where my father later came in, and that's where I was born.
A inicios de los años 60, mis padres fueron a Cuba como profesores universitarios a Santiago de Cuba.
And at the start of the 1960s, my parents went to Santiago de Cuba as university professors.
Y bueno, tuve el privilegio de crecer en la tierra donde nació el son montuno, el bolero, la vieja trova, el feeling.
And I had the privilege, therefore, of having been born in the land where the son montuno, the trova, the bolero were actually born.
Algo se me pegó.
And something of that actually stuck.
Desde 1977 vivo en Panamá, donde mi papá fue a trabajar junto al general Omar Torrijos.
60 or 77?
77.
Since 1977, I've lived in Panama, where my father went to work with General Omar Torrijos.
Participó incluso en todo el proceso de negociación de los tratados del canal, los tratados de Torrijos Castro.
And he participated in the negotiation of the Carter-Torrijos treaties.
Y mis inicios ya como cantautor son a finales de los 70 en Panamá, en época de Torrijos, en época de un proceso de cambio social.
So my start as a singer-writer, singer-composer, was in the 1970s as
un proceso de cambios sociales
in the midst of a process of rapid social change.
Que no fue solo la negociación del canal de Panamá, sino un conjunto de reformas que empiezan a hacer a la gente dueña de su propio destino.
It wasn't just the negotiation for the return of the Panama Canal, but there was also a set of processes of reform, overall reform in society.
Sin los cambios en los 70, sin esos cambios en los 70, el Panamá de hoy no sería posible.
Without those changes in the 1970s, today's Panama would not have been possible.
A pesar de traumas posteriores muy importantes como la dictadura de Noriega o la invasión norteamericana del 20 de diciembre del 89.
Yeah, despite the many traumatic events that Panama went through, such as the dictatorship of Noriega and the U.S. invasion of 20 October 1989.
La primera canción que me gustaría compartir con ustedes se llama La herencia del pelao, del niño.
The first song I'd like to share with you is entitled the Legacy of the Small Child.
Era las historias que le contaba mi abuela a mi papá cuando de niño vivían en Brasil.
At least it's based on the stories that my grandmother used to tell my father when he was a child and they lived in Brazil.
Y eran las mismas historias que mi padre me contaba a mí cuando yo era niño en Santiago de
And
Cuba.
they were the same stories that my father told me when I was a child in Santiago de Cuba.
Y es la historia que le cuento yo a mis hijos.
And those are the stories I tell my children.
La herencia del pelao. Pelao que naciste en la capital, lejos de la arcilla, donde se forjó la luz de mi derrotero. Te ayudaré a descubrir tantas maravillas si tú te adentras conmigo por sus senderos, rumbo a Colombia en Darién, huye en Chucunaque y Tuira, ruge, bunde y bulle, de allá la que me inspira. costa arriba hasta Colón.
So they're actually really important areas when we think about the global carbon cycle and carbon circulating through the atmosphere, being taken up through photosynthesis by plants. We have huge amounts of carbon stored in plant biomass in the tropics. And this map is color-coded, where the hotter colors, the reds and the pinks, have really high rates of productivity. So this is amount of carbon that's being taken from the atmosphere and stored in plants' biomass. And when we're interested in looking at current climate change and contributions of human activities to climate change, the tropics becomes an important place to look at because of its very large role both in sucking carbon out of the atmosphere, storing it in plant biomass and in soils, and returning it back to the atmosphere. And so this is important. This productivity is important in terms of the carbon cycle and climate change. But just from an ecological perspective, this high productivity, this high amount of carbon, ultimately is food available for the rest of life. And so that's one of the reasons we can sustain such high diversity in the tropics, is because of this very high plant productivity. So more recently, in the context of concern about global warming, there's been a lot of focus on looking at tropical forests and their role in the carbon cycle. Because as I mentioned, they have really high rates of net primary productivity, so they're very actively interacting with carbon concentrations in the atmosphere. And they have one of the largest share of global terrestrial carbon. If we're trying to figure out where carbon is stored on our planet, a lot of it is stored in tropical forests. And so anything that might alter carbon dynamics in tropical forests is going to strongly influence our atmospheric concentrations. Question?
Tropical forests in the United States according to that map?
No, this is actually a map of net primary productivity. And so the green areas are areas of the world that have some of the highest rates of net primary productivity. And the darkest green areas are concentrated in the tropics, but there's definitely a lot of productivity in other parts of the world as well. Good question. Please do ask questions as we go along. And so if we're looking at different sources of carbon and contributions to global warming through greenhouse gases, the most important contribution worldwide is definitely industrial fossil fuel emissions of carbon, but human activities that are altering the amount of carbon that's stored in our biomass, our plant biomass, and in our soils are second most important in contributing to greenhouse gases to the atmosphere. And more recently, in the last several decades, tropical regions are dominating the flux of carbon from plant biomass and from soils to the atmosphere. So if we're trying to manage landscapes to reduce how much carbon is being emitted to the atmosphere, one of the strategies is to focus on these changes in land use in the tropics. And you can see, I actually really like this graph because it does show that the tropical regions, this is tropical Africa, Latin America, and tropical Asia, dominating the flux of carbon in the most recent decades, but that's definitely not been the story historically. Other parts of the world, United States, at the late 1800s, beginning of the 1900s, was the most important contributor of carbon emissions due to land use change. And again, this is just looking at land use change, not taking into account industrial emissions, which are still the most important source. So what's driving this carbon flux from the landscape to the atmosphere? A lot of it is deforestation. So we're basically taking all that carbon that through productivity is being stored in our plants and soils, and through deforestation, fire, forest degradation, releasing it to the atmosphere. And there's been a lot of studies trying to quantify and identify areas all over the world where this is happening. And there's a recent study by Mitch Aide from the University of Puerto Rico, who was here a couple years ago, where they were looking at changes in land use and land cover And all these red dots are areas where the trend over the last decade has been one of forest cover, so forest cover loss. So deforestation still being a really important trend. So what's happening to these areas that are being deforested? A lot of them are being converted to agricultural crops, but in many parts of the tropics, the most important land use that comes in right after deforestation is pastures, grazing livestock, for many reasons. But here's kind of a neat reconstruction of changes in pasture cover globally over time, starting 800, 1400, 1700, 1992, and you can see the hotter red colors are greater percentage of individual pixels on a map covered in pasture. So we go from fewer parts of the world having pastures to having grazing pastures pretty much everywhere on the planet in much higher concentrations. And this is significant because we're through this major deforestation for pasture, we're reducing the amount of carbon that's stored in our plants, a lot less plant biomass in general in our pastures than we have in our forests in the background. And in addition, we're adding a new source of carbon greenhouse gases to the atmosphere, which is methane. That's produced in the guts of cattle. And as we're increasing this global production of cattle, we're increasing methane emissions to the atmosphere. And methane is actually even more powerful than carbon dioxide as a greenhouse gas. So a lot of the work that my research group is trying to do is looking at how much carbon is stored in different parts of the landscape and how human activities influence both the reservoirs, so the stocks, how much carbon, as well as the movement of carbon among different reservoirs to really try to better understand this global carbon cycle and ultimately how we're influencing concentrations in the atmosphere and how that might affect global warming. And so one of the big questions is, with our concern with global warming, is trying to predict what the magnitude of climate change is going to be in the future. And one of the most important, we have a pretty good understanding of how much carbon we've been pumping into the atmosphere, both from industrial fossil fuel emissions and from land use and land cover change. But a lot of it is disappearing from the atmosphere. A lot of it is being taken into the oceans or taken up through this productivity in plant biomass. And when we're trying to model what the extent of climate change is going to be in the future, one of the big problems is that we don't understand how much the plant biomass in our soils can take up from the atmosphere. And I like this figure. Even if you don't understand anything about this data, you can tell there's a lot of disagreement, right? It's kind of all over the place, which is the main point of this graph. These are basically, all these lines are modeled estimates of how much carbon from the atmosphere can be taken up by plants through that productivity. So it's similar to that map that I showed you of productivity into plant biomass, projected into the future, 2100. And every line represents the results from a different model. And so you can tell that we pretty much agree what's happened in the past, but projecting into the future, it's, anything is game, right? And if we're trying to predict what might happen with global warming, if we have huge carbon uptake by the atmosphere, that's good. By the terrestrial carbon, that's good, because that's carbon we're taking out of the atmosphere. So this is good. We can predict that if this scenario is right, then global warming is not going to be as bad as we think it is. But if instead of taking up carbon, we're actually giving off more carbon, then that's a really big problem. So a lot of the research we're trying to do is reduce the uncertainty in our understanding of how terrestrial carbon uptake works so that we can better predict what might happen in the future. And so two major sources of uncertainty that lead to this spread are, first, how the amount of carbon stored in vegetation can change over time on a landscape, especially in response to a human disturbance or human activity. So how carbon accumulates and changes in forests that are regrowing after a disturbance. And then also response of what's happening to carbon in the soils to environmental change. And so that's the two big questions that my research group is focused on. And we do a lot of work specifically focusing on below ground carbon because it actually stores 2 to 3 times more carbon than we have in all plant biomass or in the atmosphere. So it's a very significant store of carbon. And it can interact with the atmosphere, interacts with vegetation, and can actually respond on much shorter timescales to disturbance than we ever imagined. So a lot of the research that we end up doing is going to different parts of the landscape, especially working in tropical landscapes, and quantifying how much carbon is in our plant biomass above ground, but also how much carbon is stored in the soils under different land covers below ground, so that we have a better sense of how much is there. And then by measuring changes in stocks over time, we can also get an idea of how these very large carbon stocks are responding to disturbance to try to narrow down some uncertainty in that widespread of data. So I mentioned earlier that the dominant trend of land use and land cover change in the tropics is deforestation. But there are definitely many parts of the tropics that are experiencing pretty widespread reforestation, so increase in forest cover. And this is zooming into Central America, the top of Northern South America, and the Caribbean, where we've done a lot of our research. And all these blue dots are areas that in the period of the study, which was 10 years, showed long-term trend in forest increase. So even though globally deforestation is still really important, many parts of the world, and we see this in tropical Africa and tropical Asia as well, many parts of the world are increasing in forest cover. And this is an important trend in the tropics, but we've experienced that in Europe and North America already. So I couldn't find a very nice map for northern Wisconsin, but the same thing happened in northern Wisconsin. But this is a map of a county in central Massachusetts. Areas of green are forest cover, 1830 to 1985. Huge increase in forest cover across most of, this is just for one county, but we see the same trend across most of New England and most of the northeastern coast, driven by abandonment of agricultural lands as people move away from the farms to the cities, have other sources of income. We find the same thing in Europe. This is a map of farmland pre-1991 in the green. And then here for different counties, we get areas in the red, yellow, and red, where we have 50% abandonment of agricultural land leading to reforestation. So pretty important trend happening at a global scale. So following on that trend, we're interested in trying to figure out, well, how does carbon storage in plants and soils change over time as these landscapes reforest? What is the effect of the former land use? Does it matter what kind of agricultural crop, if it was pasture, if it was sugarcane, if you had banana plantations, if you had corn, how intensively it was managed? What effect does that have on these trajectories of succession as the forest is recovering? How does carbon change with reforestation? What type of species composition, what type of plants and trees do we get in these forests? And does that affect productivity in carbon storage and plant vegetation in soils? And ultimately, what we would like to be able to do to help those models and help reduce that uncertainty in the spread is come up with predictive models. where we understand what's happening at a particular site, but can we predict what's happening across the tropical landscapes by understanding some of the effects of these different variables. So I'm going to take you to the Caribbean, and we'll look at some case studies of where we've done a lot of our work. And the Caribbean is an excellent place to do this research. We've done most of our research in Puerto Rico and also in St. Croix, part of the US Virgin Islands. And this is a really good place to do this type of research, especially looking at agricultural abandonment and reforestation, because these islands have experienced massive agricultural abandonment and reforestation. And we have really good historical records. Many parts of the tropics have had pretty dynamic changes in forest cover, but we don't really have very good historical records. So it's really hard to know what happened on that landscape in the past. But in the Caribbean, and especially Puerto Rico, we've got centuries worth of historical data on forest cover, even species composition, because of a very long-term presence of forestry research and management on that island. So let's look at deforestation and reforestation in the Caribbean. And so this is a historical photograph from the 1940s, what most of Puerto Rico looked like at that time period. We had 90% deforestation of the island for mostly pasture, sugarcane, and small-scale kind of subsistence agriculture, pretty massive deforestation island-wide. So another historical photograph of Puerto Rico, where you see one of the dominant land uses, especially in the flatlands, was sugarcane plantation. So we go from 90% of the island being completely deforested to today having 40 to 60% of the island in forest cover. 40% at the island-wide, and some areas 60% where we work. So massive reforestation. So definitely just even thinking about those numbers and looking at these pictures, this landscape, 40, 50, 60 years ago looked like this. And now we have massive increase in forest cover. Some of the main drivers for this have been changes in the economy from one of these agricultural economy to an industry and services economy. Also widespread migration from rural areas to urban areas. But in the 40s and 50s, a lot of this natural reforestation, most of this is natural reforestation, was driven also by migrations from the island to the mainland, driven by economic drivers. So this actually gives us a really nice opportunity